diode as voltage regulator, diode as rectifier, and in power supply circuit. Okay, so okay, let me shut my camera first. Okay, all right, so this is the introduction for today's class. Okay, so I will introduce you the block in basic power supply, and then the diode operation as power supply. Okay, the rectifier. Okay, full wave rectifier, and also rectifier with capacitor filter, and Xenon diode as voltage regulator. First of all, so diode application. So we know that. Okay, so up to today, you have been introduced with diode. Okay, so you know that diode is a combination of p-n junction. So this is your symbol of diode. So diode is to allow currents to flow, okay, in one direction. Okay, if you have a circuit, okay, you might want to make it either current can flow it or current couldn't flow through the loop. Okay, so you put a diode. Okay, if you want to make your current to pass through the loop, you need to make your diode in forward bias. Okay, I think you all remember about this, right? Okay, and if you won't allow, okay, you don't want to allow the current to pass through or to flow through in your circuit, you make it forward bias, because when diode in forward bias, it will behave like open circuit. Okay, so by using this kind of characteristic, we are actually able to change the power supply. Okay, for example, you have power supply a sinusoidal input. Okay, now your objective is to make your power supply, or and this one is voltage, okay, into a DC voltage. Okay, so this is your AC input, and you want to have a direct current instead of a AC input where you have alternate current, a sinusoidal input, okay, like the top figure I'm showing now. Now you want to have a direct current output voltage. Okay, so which means that you have, for example, you want a straight line voltage, very straightforward voltage, for example 10 volt. So how you want to transform from this, okay, AC input to the DC output? So then it comes with this rectifier. Okay, so you're gonna have a power supply. So how you transform your power supply from AC input to the DC output? So this is all about on today's lecture. Okay. Okay, so linear power supply. All right, so I think up to now you know that we have two type of power supply. Okay, so AC, where you have a sinusoidal input, like I've shown you just now. Okay, for this case, for example, it has 240 volt for 50 hertz. Okay, to DC, you want to convert to the DC direct current voltage. Okay, so how to transform from AC to DC, you might need to have three fundamental components in your power supply circuit, which are, the first one is rectifier circuit. Okay, the second one is filter. The third one is regulator. So this circuit is not separated. Okay, it is actually connected to each other. But the first stage of your power supply circuit, okay, you might see your transformer first. Okay, this is your transformer here. Okay, so transformer, it's either you want to transform step up or step down. I think you all familiar with that. And then you have a rectifier, and then filter. Okay, for rectifier, circuit, you were gonna have a circuit that include a diode. Okay, for filter circuit, you would have, so filter means you will filter out noises. Okay, so the only component that is suitable for this kind of circuit is capacitor. Okay, if you still remember capacitor is to store charge and as well as to discharge. Okay, it will discharge all the noises. You have seen this in your ECA. okay, in your ECE subject. So we use capacitor in this case, okay. And also, at the end of your power supply circuit, you're gonna have a voltage regulator. For this case, we gonna use sorry, what I'm drawing here. We gonna use what is this? Okay, so this is diode. Okay, so this is capacitor. Okay, so what is this? The last one, the third one?
Zener diode.
All right, Zener diode. Correct. Okay. Yeah, I know you all know, but at least respond so that it's kind of work two ways lah. It's not 100% two ways, but at least 90%, 10% from you. Okay. All right, so DC supply, okay, DC power supply. So this is what I'm talking about just now. So what is DC power supply? It is a basic function of DC power supply to convert from AC to a smooth DC. Okay, to a smooth DC. If you can see the word smooth here, so smooth means that we have a very smooth straight line like this. Okay, if we didn't use, so this is how it looks like, student. Okay, so this is how your power supply circuit looks like. Okay, you might not know what happened when you plug in your voltage. When you go in the lab, you have a sinusoidal input, but then the output become a straight line DC voltage. Okay, so what happened in it is here. Okay, so you have your transformer here. So this is your sinusoidal input. Okay, for example, the input is 10 volt. Okay, and then you have a rectifier circuit. Okay, so this has its own function, and then you have a filter circuit. Okay, after you filter the circuit, actually, so in here you might get after you rectify the circuit, you might get output with noises. Okay, and then you filter out noises, you will be able to get a straight filter voltage like this. Okay, and then you use regulator. Okay, for example, your output voltage here is 12 volt, but you only want your output to be 10 volt. So you use voltage regulator with a Zener diode, okay, to limit or to regulate your voltage become 10 volt. That is just an example. Okay, and then finally you put a load. So this load usually represents as a resistor. Okay, load resistor. All right. Okay, so this is how it looks like. Okay, like I said just now, so you have transformer. So transformer, I think you all familiar that it is step up or step down transformer. Okay, so we'll show you in the example next. And then you have a rectifier. So this is how it looks like, the output for transformer. For example, it is a step down transformer. So you have the magnitude a little bit larger. Okay, and then the magnitude of the output of the transformer a little bit lower. So this is step down, for example. Okay, it could be a step up transformer. Okay, and then you still get, although transformer didn't transform your input signal. Okay, it's just will be the sinusoidal as well. Okay, and then you will get a rectifier. Okay, rectifier circuit. So rectifier circuit in here involved with diode. Okay, so you have diode, like it is a diode circuit actually in here. Okay, so this rectifier will actually converts your input voltage to a pulsating DC voltage. Okay, now as you can see, all the we want positive voltage, so all the positive voltage wave cycle will be positive. However, for the negative one, okay, will be converted, okay, into positive. Okay, and so on. Okay, we have a continuous continuous AC signal. So and so on. The negative one will be converted to the positive one. Okay, so this is the function of rectifier. Okay, and then remember, your objective is to get from a sinusoidal to a straight line DC output here. Okay, you have a pulsating DC voltage here. Okay, and then from this output, okay, rectified output, okay, it will meet a filter. So this filter actually a capacitor. Okay, capacitor. Okay, it will filter out all the noises and fluctuation of this rectified voltage, okay, and produce a smooth DC voltage. But you can see here, you are actually getting almost a straight line, okay, with a little bit, means that all the noises has been filtered out, almost straight line actually from here, but a little bit ripple, with ripple a bit, okay, with ripple. Okay, so how we want to filter, how we want to make this ripple to regulate it into a straight line? We use a voltage regulator. So this one, we use a Zener diode. Okay, and then you will get a straight line here. Okay, so the regulator usually to maintain a constant DC voltage. Okay, for variation in the input line voltage in the load. Okay, finally you have a load. So why we have a load? So this load is actually RL. Okay, so why we put load resistor? Because we want to limit current in any circuits. Okay, we put resistor because we want to limit the current. Okay, unless your output will be with leakages. Okay. So this is the transform couple input. So this is how it looks like. Okay, like I said just now, from 2 to 1 means this kind of example has a step down transformer. Okay, let's take a look at the example. So these are the advantage. Okay, so it allows source voltage to be step up or to be step down. Okay, and the AC source electrically isolated from the rectifier. Okay, and this is to prevent a shock hazard in the secondary circuit. So secondary circuit here is after rectifier, where you have other circuit, okay, outside circuit other than the power supply. Okay, and then this is your transformer. Okay, so you know that's for step up transformer. This is the formula. I think you all familiar with this. Okay, so N is the number of coil, if you still remember. So secondary over primary, V secondary over V primary. So this is actually the voltage of the input and output of the transformer. Primary means at the left side, secondary means at the right side of the transformer. So this is how it looks like from the oscilloscope view. Okay, so rectifier. So what is rectifier? So from AC, you will get a pulsating voltage like this. Okay, no more negative, all become pulsating. So rectification means improvement or cure. Okay, for a sinusoidal waveform or any supply that has a variation of input, okay, we can use diode, okay, to rectify the signal. Means that diode allows current to pass through, right? So means it's allowing the positive wave only, okay, the positive cycle only, not the negative cycle. So in this case, rectification are used to modify the input value to become only the signal that we wanted. Okay, and then rectifier, it has two type of circuit rectifier. One is half wave rectifier, the second one is full wave rectifier. But for your syllabus, we will only cover the full wave rectifier. Okay, all right. So when it comes with the transformer, so these are the I think the terms that you should know lah. Okay, when you want to convert from AC to DC, so so the final voltage will be, we call it as a V average. Okay, V average means if you have a rectified circuit, okay, sorry, a rectified signal like this, so what voltage we gonna take as a DC voltage? Okay, so this one we call it as a V average. Okay, so this is your peak value. VP is represent as the V peak, okay, peak voltage. Okay, peak voltage, and this one is the average voltage. Okay, in here, so it might say that the average voltage is actually the center of this cycle. Okay, center of this cycle. So usually V average is determined by finding the area, but then we can actually say that V average, okay, this V average here is equal to your VDC. Okay, some will ask you what is VDC. So VDC is actually equals to the V average. Okay, so the one that you get here is a peak voltage, V peak, but you can actually convert it to the V average or VDC by using this formula. So VDC for the case of full wave rectifier, since your syllabus only cover full wave rectifier, is equal to this equation. Okay, 2 V peak over pi. So V peak here is represent as this voltage. Okay, how much the value? We will take a look at the example later. All right, so you're going to use this formula. And then other than that, okay, some transformer give you in a term of normal voltage. Okay, voltage, for example, your transformer has 110 volt with 60 hertz 60 hertz frequency, something like that. Some transformer will give you in terms of RMS value. Okay, RMS value, root mean square value. Okay, so this is used for time varying. Okay, but this RMS value, okay, you can convert it. Okay, so V RMS value must be converted to the V peak. So how you convert it to the V peak? Okay, by using this formula. So V RMS square is equal to the V square over 2. Okay, for this case, it is actually VRMS equal to the 0.707 VP. Okay, so we will look at the example later. But where is actually, so from here, okay, because why you convert it into V peak is all the calculation, okay, all the calculation make it standardized. Okay, at first place, when you get the transformer voltage in RMS, you have to convert it in peak value. Okay, so it is the standard procedure that you should do. So but you might want to know where is the location for B peak, VRMS, and VDC. So this is how it looks like. So the V peak is at the maximum point, okay, of your sinusoidal of your rectified signal. Okay, VDC is somewhere below the VRMS. So VRMS is here lah. So VDC is actually the real value, okay, the real value of the voltage. Right? Okay. So we'll take a look at the example. So other parameter is peak inverse voltage, PIV. So this PIV is the maximum reverse bias, okay, that a diode will be exposed to. Okay, means that if the diode in reverse bias, what are the maximum peak voltage that can the diode allow to pass through? Okay, so this is PIV, peak inverse voltage. So it determines the minimum allowable value, okay, B breakdown of any diode used in the circuit. So voltage rating must not be exceeded in the reverse bias region. So this one, I'll show you in the example lah, okay. So it has formula actually to calculate the PIV. So many terms has to be introduced here before we look at the real example. Okay, so this is the full wave rectifier, okay, allows current. So it has, again, for the rectifier, it has two types. One is center tap transformer. The other one is bridge network circuit. Okay, so these are all diode circuit. Okay, diode circuit. But the configuration are different between these two. Center tap are different, but bridge network are different. But then your output, no matter it is a center tap rectifier or a bridge network rectifier, finally you will get this output lah after your rectifier circuit. Okay, from sinusoidal to pulsating DC output like this. Okay, to full wave output, no negative wave. Okay. Alright, so V average is given that equation, and then VRMS is actually V peak over square root 2. Okay, so I am actually put it again, but it is actually the same equation as in the previous slide. Okay. All right, so this is how it looks like. Okay, so this is the first type of your rectifier. Okay, this one. Okay, the center tap rectifier. Okay, so we were looking at the first one, the center tap rectifier. So how the center tap rectifier looks like I say, it is a diode circuit, but the configuration are different. So this is how it looks like. Okay, so you have transformer. Okay, you have transformer. So this is your transformer. Oh, so excuse for my handwriting. So I better write it this way. Okay, so this is your transformer. Okay, and this is your, when I write center tap, means center tap full wave rectifier. Okay, CT, center tap full wave rectifier. So this is the rectifier circuit. So this is how it looks like for center tap circuit. Okay, it has two diode, D1 and D2, and then it has ground at the center of the transformer output secondary here. So when you have output here, when you have transformer, so the left side is your V primary, the right side is your V secondary. I think you all know. So at V secondary here, there is a ground. So how it looks like here, so since there is a ground at the center here, so the voltage secondary, so you have voltage secondary here plus minus, okay, but then it has ground over here, so the output will be divided into two, which is V secondary over 2 on top and V secondary over 2 on the bottom, okay, in the bottom like that. So this is how it looks like for the center tap. Okay, so how it works, okay, let me show you the how it works now. Okay, all right. Can you give me 2 seconds?
Oh, yes, sir.
Yes.
Okay, I'm back. All right, so how it works, okay, let me show you. Okay, so remember that so this is your sinusoidal input. Okay, your objective is to get the output of this rectifier. You must get this, okay, this one like this, okay, like this. Okay, so how? Okay, let me show you in the next slide. Okay, so this is how it looks like. Okay, so let's take a look, okay, on the first positive cycle. So this is first positive cycle. Okay, positive cycle. Can you give me 10 seconds, please? Wait, eh? Sorry all, I'm back. Okay. So, okay, let's see for first positive cycle. Okay, let's take a look on the previous. Can you hear me all?
Yes, doctor.
Yes, yes.
Okay,
Yes.
okay. So this is your input signal. Okay, no matter how many cycle you have, okay, like you have, this is 1 cycle, 2 cycle, 3 cycle, no matter what, you need to solve the positive cycle 1. Okay. Okay, so this is the positive cycle 1. Okay, this is the negative cycle 1. Okay, when I write plus VE, it means positive. Negative VE means negative. Okay, so now we want to solve it one by one. Okay, let's take a look for the positive cycle 1. Okay, this cycle. Okay, this cycle. All right, for the positive cycle. Can I write again? Okay, so this is number 1 for positive cycle. Okay, now positive cycle. Okay, so when you have, so this is your input, since this is plus, so plus on top, negative bottom. Okay, so this is your V primary. We assume that this has the same ratio. Okay, later we look example might have different ratio. And the left one is V secondary. The right one, the left one V primary and the second one V secondary. And you have, okay, since this is center type where you have at the center, so the notation will be positive on top because this is positive cycle, and negative here, positive here, negative here. So this is how it looks. Okay. All right. So let's take a look here. Okay, what happened here? All right. So first thing, okay. Let's take a look at the first one. Okay. So for this one. Okay, for this one, okay, let's take a look at the top one. Okay, this one. Okay, so you have, you know that when you have circuit, okay, when you have circuit, plus, minus, and then the resistor here. So the loop will be like this. Okay, so plus minus current is going up. Okay, from negative to positive. Okay, so as in this case, same thing. Okay, so I will use the red one. So you will have current from negative to positive in this direction. Okay, so this is your direction of current. Okay, now let's take a look here. So for this case, since current is going to this plus of your diode, so what happened to the diode 1 for this case?
Forward bias.
Yes, diode 1 forward bias and diode 1 is turned on.
On.
Okay, turns on. Okay, so let's let me draw again. Okay, so for example, for this case, so let me draw the equivalent circuit. Okay, so you have a diode 1 here. Okay, diode 1, and then this diode 1, the anode 1 is connected to positive here. Okay, positive. Okay, and then you have, of course, when you have positive, you have negative. Okay, and then diode 1, this diode 1, okay, it makes your resistor. Okay, you have your RL resistor here, RL resistor, and the ground. Okay, now you want your output voltage. Okay, so where is your output voltage? So output voltage is always at your RL. Okay, always at your RL. So this would be your output voltage. Okay, so this is RL and this is your V out. Okay, now you want to get your V out value. Okay, your V out value. So now it is simple. Why simple? You already know the KVL stuff thing. You already know here. So this is, what is the voltage here? V secondary. What is the voltage here? Okay, so this is center tap. Okay, center tap. So from plus here to here is V secondary. So it's because we have ground in the center, so you have V secondary over 2. So the voltage across here is actually V secondary over 2. Okay. Who has problem now? Please ask now so that I can continue. All of you understand? Clear or not?
Yes, Doctor.
Clear, clear.
Okay, great. Okay, so if all of you,
Doctor,
yes, yes.
V secondary over 2, and 2 is V peak, right?
Yes, we pick.
Oh,
Pick
okay, Doctor.
everything is picked value. Okay, all right. Okay. All right, so V secondary over 2. Okay, now, okay, let's assume this D1, okay, no matter what D1 is silicon ke, ideal diode or whatever diode, but still current can pass through this circuit and you can get your V out. If, let's say, we assume diode is ideal, so what happened to this diode when it is forward bias? What
Short
happened?
circuit.
Short circuit.
Yes, it will be short circuit. Means that V out equal to what?
V
V
secondary
secondary
over
over
2.
Correct. V secondary over 2. So in this particular example, okay, in this particular example, you will get that, in this particular cycle, positive cycle, you will be able to get the V out value here. Okay, because diode forward bias and you able to get your V out. Okay. So this is for the case of forward bias. Okay, forward bias. All right. Now, okay. So I would like to summarize. Okay. So what happened to the D2? Okay, what happened to the D2? Okay, during positive cycle. Okay, remember. Okay, listen very carefully. Okay, so your objective is your input cycle here for positive cycle. Okay, you want to make use of this rectifier circuit. You want to make use of this diode. Okay, to pass to make your current to flow lah. Okay, in one direction. Okay, you have two options in this positive cycle. You have two options actually. You have either the current can flow through D1 or through D2. Okay, now I'm taking D1, okay, because your current can pass through like this because you want to make your diode one forward bias. Okay, your objective is to get your output voltage. Okay, when you do this loop, okay, when you apply this loop, okay, the red one here, okay, from negative to plus and then current go in positive. Oh, D1 is forward bias. Then you will be able to get your V out. Okay, now let's take a look at D2. Okay, what happened to the D2 here? Okay, so now D2 here, okay, so D2, this is your anode. Okay, this is your anode plus minus, but then so current is so now current is this way, okay, from negative to positive. Okay, so the loop now is vice versa. Okay, the vice versa, it will be your loop will be like this. Okay, like this in different direction like this. So what happened to the diode 2? So now current is going into the negative of diode. So diode 2, what happened? What happened to the diode 2? Hello?
Reverse
Doctor.
bias.
Yes, diode 2 is reverse bias and therefore diode 2 is off. But doesn't matter because you have two options. It's either your current can pass through D1. Yes, it can pass through D1 and D1 mix. So D1 become forward bias. Doesn't matter. I have option. I can flow current set. I can flow to the D1 to go to my output, to my final destination, which is RL. So I can make use of this D1, okay, to flow to the output. Okay, because D2 didn't allow me to pass through. D2 become reverse bias. That's fine as long as I can get this V out. Okay, that is for the first cycle, okay, for the positive cycle. Like I said, you only have 2 cycles. Positive cycle settle. Now, let's take a look on the negative cycle. Okay, negative cycle, I will use a different ink. Green. Green. Okay, all right, so negative cycle. So, number 2 is for this one, okay, negative cycle. Okay, for negative cycle, for this case, okay, for negative cycle, you have, so you know that you have this V primary. So this is negative, okay, negative. So we have V primary. So in here, you are making that, so this is the standard procedure, okay. So when plus positive cycle, the top is plus. Okay, when negative cycle, the top is negative. Now, negative, the bottom one become positive, okay. Again, you have a V secondary here. So since it is center tap, so here is V secondary over 2, and the bottom one also V secondary over 2. Okay, so this is V secondary over 2. All right, so let's take a look on the first one. Okay, on the first one, so since you have negative and then plus here, let's take a look at the D1 first. Okay, D1, so this is vice versa. Okay, you know that current is in this direction. Okay, in this direction, so means that current going like this. Okay, so what happened to your D1 here? So current is now going into the negative, to the cathode. So what happened to your D1?
RB.
Okay, RB, correct. Reverse bias means this is off. Okay, off. Doesn't matter. All right. So now let's take a look. Okay. If I would want to draw this, okay. Okay, so can I go back to the positive cycle? Back, okay. So this positive cycle, okay, this one is actually represent this positive cycle. So positive that will turn out to become positive. Okay, now we are looking at this, the second cycle, which is negative. So this negative will turn out into what? So let's take a look here. So your first option to use D1 seems fail, reverse bias. But you have other option, which is D2. Okay, so let's take a look here. So in D2, so current is always in the from negative to plus, so it will flow into this direction to the V out. So current is flowing into that direction. So now current is going in your anode. Therefore, your D2 will become forward or reverse?
Forward.
Forward bias. Yes, forward bias. Why I'm going it slow? Because I need you to understand. Okay. So forward bias. Now, for this case of negative cycle, it has option for D2 to make it a current to pass through from the input to the RL. Okay. In here, so let's draw the circuit. Okay. So let's draw the circuit. So you have this circuit would be, I will draw like this. So you have your D2 here. Okay. And then, sorry, draw again D2. Okay. So this is your D2. Okay. D2 negative connected to RL. If you go here, so it is connected to RL. So you have RL here. Okay, RL. This is your RL. Okay, and this is your ground. And then plus D2 here, plus D2 you have plus V secondary. Okay, you might have to think to rotate your head. Okay, so you have plus means that anode of your diode connected to plus of V secondary. So this is how it looks like. So This one will become, so can I write this portion into the other side? So this D2 become forward bias, okay, and therefore this one will become V secondary over 2, and then the other side negative will go to the ground, so go to ground. So this is how it looks like your equivalent circuit. Okay, for this particular case, your negative cycle here, it will turn out you get positive. Okay, positive. Okay, so how you confirm is this positive? Let's think of the D2 here is ideal diode. This is ideal diode. So means that it will short circuit. So V out will be equal to positive V secondary over 2. That's why you will get the portion here positive. Okay. So this is the objective of your full wave rectifier. Okay. When you have a positive input cycle, it will turn out get positive output. Okay. When you have negative input cycle, you still will turn out getting a positive output cycle here. Okay. So this is how center tap works. All right. So it has two options, either D1 or D2. So it will choose either way. Okay. Usually the circuit is fixed like this. Okay. So you can just apply one loop here, and you said that D1 forward bias, you know that the other D2 will be other way around, off. So you just state that D2 off, and then you draw the equivalent circuit and write down the KVL. Okay, and then you get the V out value. Okay, we'll take a look at the example later with values so that you can imagine. Okay, and for the negative cycle, okay, you know that D2, D1 reverse bias. You just write down the statement like that, and D2 forward bias, and you draw the equivalent circuit like this. You get the V out, and you draw the output value here positive. Okay, this is how it. So, do you have any question before I go further? Okay, so before that, student, okay, I think I need to do this. Okay. Okay, let's write down the KVL for this one. Okay, can someone give the KVL? I might want to call names here. All right, so Alisa Nabila. So what is the KVL for the top one here for this circuit? For this circuit, what is the KVL? Anissa Nabila here? Yes. So can you use your mic? Cannot. We can't hear you. Might be your mic problem. It's okay. So, all right. Okay, doesn't matter. Amina Khatun. Amina Khatun. Is Amina Khatun here? It's okay, doesn't matter, Alisa. It's okay. Is Amina Khatun here? Okay, no response. I'll start with A, okay? I think I'll go with Amir Shazwan. Is Amir Shazwan here?
Yes, doctor.
All right. So what is the KVL for this particular circuit, the red circuit one? Amir?
Negative V second over 2.
Yes, correct.
Uh,
Negative. Wait, let me write. V secondary over 2. Okay.
plus VD1.
Okay, correct. Again?
Plus IRL.
Okay, correct. Or can I write V out straight away? Can, right?
Yes.
Yes, V out equal to 0. Okay, so this is your KVL. Okay, no matter what is VD1 is either, thank you, Amir. VD1 is either diode or silicon, so you have to do the KVL circuit lah. So this is how it looks like, the KVL circuit. Okay, all right. Okay, so for the bottom one, can no need lah. I think it will be the same. Okay, will be the same. So the KVL will give you like this. Okay, so V secondary over 2 plus VD2 plus V out equal to 0. Okay, will be the same KVL. So that's how you find the value for V out. All right. Okay. So before I move forward, do you have any question regarding this? Okay, so Lei Yong asked. So Lei Yong asked in the group. Amina Khatun said, sorry, I have some problem with my microphone. Okay, it's okay. All right. So Lei Yong asked me, may I know what happened if the diode are pointing to different direction? For example, the upper one to the right and the lower one to the left. Or is this connection possible? Oh, okay. If the diode is in vice versa, means that Lei Yong said, where is my drawing here? Did I go to, oh, okay. All right. Okay. So Lei Yong said, what happened if this is going to the left and this is going to the left? Again, what is the question, Lei Yong? The diode direction, the upper one to the right and the lower one to the left. Oh, okay. Doesn't matter if what is the connection, as long as you can find this current, okay, from input to output. Okay, current is possible to make the diode become forward bias. That is possible. If it's not, then that means that you would get this voltage. You will get the zero lah. Okay, means that all can become reverse bias and you won't be able to get this lah. Your VR will be equal to 0. Okay, so as long as, doesn't matter Lei Yong, doesn't matter if let's say the connection is vice versa or not, as long as you find the direction, okay, of current to pass through your diode, means you'll be able to get your V out. It's possible. Okay. Okay, other question? From Mantur, why is not opposite? Why? Because it is, why is not opposite? I don't understand. So in general center tab, okay, this is how it looks like. Okay, why it's not opposite? It depends. Okay, it could be maybe your output here start negative cycle first, then it become positive. That will make sense. Okay, as long as you apply this cycle, okay, the step-by-step cycle, then you will be able to get your current to pass through the diode and making the diode forward bias. That will be possible. Okay, I mean VD. Who said VD? I mean Montezet was not
Yes, doctor.
opposite.
I meant,
All
doctor,
right.
for the second circuit. Like
For the
about,
what?
I'm asking for the KVL. Can you explain it, please?
For the KBL, why not opposite? What you mean?
I mean for the VD2.
VD2, okay.
Yes.
This
Can
one,
you
like
explain why
this.
we put in the KVL?
This KBL?
Yes, please.
So this KBL, why not opposite? Okay, so this KVL is actually represent this circuit, Manthur. Okay, so this circuit is actually from here just now. Okay, from here. So you have D2 plus minus. We have D2 plus minus like this. Okay, and then the plus here connected to the plus V secondary. Okay, plus V secondary. Okay, and then the negative here connected to the resistor RL, like this, and then you have ground. Of course, the other part of the V secondary over 2 ground, so connected to ground like this. Okay, and then why you say no opposite? Because my way in the first ever class, Okay, I said that the current is flowing through to the upward, okay, from negative to plus, okay. So it's always going upward like this, okay. Current always coming out from the plus, okay, from the plus, coming out from the plus and go back to the negative. So this is the clockwise cycle of the current. So this is your loop, okay, and then you apply KBL. Okay, so your friend just now are taking the first terminal, okay, negative first, okay, and then plus, okay. Mine just now, okay, I'm taking the negative, the second terminal. It could be the negative terminal first, doesn't matter, same thing, okay. So if I'm taking the second terminal, so it will be plus V secondary over 2. And then the next one also I'm taking, oh, sorry here. Thank you. I was wrong here. Okay. So the first one is, let's say I'm taking the first cycle here like this. Okay. So I got here. So this is error here. So plus means that I'm taking the first one. This is negative. Okay. And then I'm taking the first one here also positive. Okay. And then I'm taking here first one positive. Okay. If you want to make your cycle, the second cycle first, you can also make V. It will be V plus V secondary over 2. And then the second cycle is negative VD2. And then the second one is negative V0. Okay. Am I answering your question, Mantur? Mantur?
Yes, yes, doctor. Thank you very much
All
for
right.
explaining.
Welcome. Okay. Thank you for realizing the wrong there. Okay, for the second circuit, Mantu, okay, the same question. Okay, doctor, I don't really understand why V secondary over 2, V secondary over ground, because it is divided into 2. Okay, it is divided into 2. So now for this one, okay, the name itself is center tap. So it is being tapped at the center of the transformer, become ground. Okay, so the voltage here will become half top, half bottom. That's why it becomes V secondary over 2 at the top, V secondary over 2 at the bottom. Right? And then your question, why there is opposite polarity for D2? Okay, thank you, Dr. May answer. Okay, all right. I think that's it. Okay, all right. Up to here, do you all understand? So this is just, oh, I'm taking 1 hour to explain this. All right, but at least you all clear, right, about all this. Let's take a look on the example. Okay, before we take a look, before we take 5. Okay, so I would like to continue a bit. Okay, all right. Okay, so like I said just now, we have the PIV, peak inverse voltage. So peak inverse voltage is the voltage, the maximum voltage possible, okay, when the diode is reverse bias. Okay, when the diode is reverse bias, you can calculate the peak inverse voltage or the maximum voltage that the that reverse bias diode can allow to pass through. So what is the peak inverse voltage is given by this equation. Okay, V peak secondary, okay, V peak secondary over 2 plus V naught. Okay, so it is actually during first half of the cycle here. Okay, when the top transformer secondary is positive, D1 will conduct current, right? Just now, D1 will conduct current and offers almost zero resistance, means that this is forward bias or turn on. Okay, for this case, D2 will give you off. Okay, D2 will give you off because since D2 is off and you reverse bias, you can calculate the peak inverse voltage. Okay, so you calculate the peak inverse voltage across D2 is given by this equation. All right, so before we move on to this example, so this is past test example of the rectifier circuit, full wave rectifier circuit center tap. Okay, so we may take a break now. Is that okay?
Yeah,
Sure, doctor.
Yes, 5-minute break. Okay. All right. Hi all. I'm back. Okay. I didn't realize that I took like almost an hour to explain that, but I hope that you understand. So to test your understanding, let's try example, okay? Okay, so this is kind of example and kind of test question. Okay, hello all, are you all there?
Yes,
Yeah,
Yes,
doctor.
doctor.
Yes, yes.
All right. Okay, great. Okay, so let's try this question. Okay, so refer to the Q3. Okay, so it is actually the input line voltage in 120 volt RMS. Okay, this is 120 sebenarnya. Okay, this is 120 volt RMS. Oh my God. Excuse my handwriting. Very bad. Okay, 120. And then the transformer secondary winding. Okay, this is what I said just now. Okay. So from what I said just now, I said that it could be step down or step up, something like that. Okay, so this is step down where 5:1. Okay, and drive the output. Okay, what can you see the difference between? So this is actually center type. This is center type. Although it is not written in the question, written the question, but it is a little bit different, right, from what I've shown you the theory one. So the theory one looks like this, where you have your resistor. Okay, follow me step by step. Okay, so you have D1 here, and then D1 is connected to the plus RL. Okay, and then RL, of course, it will go, the negative will go to the ground. Okay, always your circuit will end at the ground. Okay, so instead of drawing a straightforward like this, so your test will drawn it the other way around, but still this side of the diode, okay, connecting to the RL, and the other RL, which is negative, go to the ground. Okay, the same ground as center tap. Okay, but then in order for you to understand, you need to draw again the equivalent circuit. Okay, let's take a look here. Okay, so now let the first step first. Okay, student, draw the label and completely draw the output waveform V out at the RL. Okay, let's go together. Okay, so this is the solution. Okay, so this is the solution. So so this is a solution. So you have this, all right? So you know that this is 120, okay, 120 volt RMS. First thing first, you have to convert your VRMS into peak. So how do you convert your so you have here is primary. So this is your V primary. So this is your V secondary. Okay. So V primary, now I want to convert into peak. Okay. So V primary peak is equal to what? What is the formula just now, student?
0.707.
So the formula just now, okay, it's okay lah. We go back, we go back. Okay. We go back. Okay, so V RMS is equal to V peak over SEEE1073. Okay, this formula, students. Okay, now you want to convert from RMS to peak. Therefore, V peak is equal to V RMS times SEEE1073. Okay, SEEE means square root. Okay, so V RMS times square root 2. So you have 120. Okay, times SEEE1073. So can anyone calculate? Where is my calculator? Okay, can anyone calculate for me?
169.7, doctor.
Okay, 169.7 volt. Okay, not finished yet. So you just about to get your V secondary value. Okay, so you know that. So V secondary. So now, V primary is 169.7. Now, can you get your V secondary peak value? What will be your V secondary peak value? This is step down. Therefore, V secondary equals to what? Students.
First, we must use n secondary over
Yes.
n prime.
Yes. Correct. Pandai. Okay. So V secondary peak, since this is step down with the ratio 5:1, therefore V secondary peak is equal to 169.7 over 5. So you will get the value here, 30.
33.94. I got.
Okay, 33.94. So this is your answer, okay, for V secondary. Okay, for V secondary. Okay, now let's go back to our circle business just now. Okay, up to now you already got your V secondary and also your V primary. Okay, now is to do the positive cycle things lah. Okay, so first thing, okay, number one, for positive cycle. Okay, although here you didn't write, so see it is sinusoidal input. So now you are solving for the first positive cycle first. Okay, for this case, positive cycle, you know that for this part it will be positive, negative, positive, negative. Okay, so what will be the voltage across here, dear student? V secondary
Over 2.
2. Yes. Okay. Okay. For this case, okay, you know, you already expert. Okay, since the arrow of the diode are still the same, okay, normally will be like that. So, which diode is forward bias?
D1. Diode 1.
D1.
Yes, diode 1. Okay, diode 1 will be forward bias. Okay, like I said, current will go from going upward like this. Okay, from positive and go back to negative, and it will go in this direction, plus, minus, and it will go to positive V naught and go back to the ground. So this is how your loops look like. Okay, your loop look like that. Okay, so from here, okay, from here, I always want to draw again so that you could see lah what happened. Okay, you can see. So if I draw again the circuit, you will get plus, okay, minus. Okay, if you don't want to draw again, doesn't matter. Okay, you can straight away, you know, V secondary over 2 and then plus V secondary mat D1. Okay, and then we know in this case, you just write here, my dear student, D1 forward bias. Okay, all right, for this case, and then you have RL, the same thing, okay, met RL, and then this is V naught, and then the other one go to negative and ground. Okay, so this is how it looks like your circuit. Okay, let's go back to the question. So what type of diode is that? Can you figure it out? Can you read the question?
Silicon diode.
Correct. It is silicon diode. Therefore, the voltage drop of silicon diode here will be?
0.7.
Correct. So this one will be replaced with 0.7 volt. Okay. Are you all clear? Are you all clear?
Yes, doctor.
Okay, great. Okay, clear. Okay. So, all right. The KVL here. KVL. What will be the KVL?
Negative V secondary over 2
Mm-hmm.
plus 0.7 volt
Mm-hmm.
plus V output.
Yes, plus V output. Now for this case, since everything in peak, so your V output also in peak equal to 0. Okay, can someone calculate for me V output peak equals to what value?
16.27 volt.
Yes, doctor.
Alright, okay. Since two students got the same answer, okay, same value, I believe this is the correct one. Okay, so 16.27 volt. Alright, great. So this is the answer. Okay. Now, okay, we don't want to make your head become headache. Okay, let's just pass through what happened to the D2 here. Okay, let's think about it like a glance through. Okay, since this is plus, this is minus, therefore it is vice versa. Okay, the current connection is vice versa. All right, so it will be into this direction. So when into this direction, what happened to the D2?
Reverse bias.
Reverse
Okay,
bias.
reverse bias. So you don't bother about it, eh? Okay, only D1. So it's okay. During positive cycle, it has option D1. Okay, it has option current to pass through across D1 to the V out. And then finally, you able to get your V out. Okay, next. Okay, next. We want to do for the negative cycle. Okay, for the negative cycle. Oh, this is what I like. Okay, this is the only thing I like lah uh during during what? During online, so where I can copy this and I don't have to draw it again. So can use different color here. So this is for negative cycle.
Doctor, we are viewing a different window.
Alamak, yeah, wait can you wait? How about now?
Yeah.
Ta-da!
Yeah, it's correct now.
I finished drawing. Okay, now I draw another one. I copy another one because I need to show you for the negative cycle by using different color. Okay, so for positive cycle, for negative cycle. Okay, for the negative cycle. Okay, all right. So now you have the same thing, the same value here. Okay, but then now you have negative cycle, means that negative plus negative plus. Okay, for this negative plus negative plus negative plus. Okay, so let's take a look. Okay, from your glance through, which diode is forward bias in this case. So you have current in this direction. Okay, and going to the D2 like this and go back to the V out. So this is your current direction. So in this case, diode D2 will be forward
Forward
bias.
bias.
Forward bias.
Yes, on. Okay, let's go straight away. So how about the diode D1? How about diode D1?
Reverse bias.
Yes, so current in opposite direction like this. Okay, so D1 reverse bias, but doesn't matter. You have option D2. Okay, so now let me draw again. Okay, let me draw again the equivalent circuit. So equivalent circuit will be, so you know that here is V second. Okay, so if I just draw it on top here, so this is V secondary over 2. Okay, V secondary over 2. So if I want okay, you might have to mirror your head. Okay, so I want to draw it. Doesn't matter. Okay, if I draw it in what way? Okay, but I want to draw it like this. So this is D2. Okay, D2 plus D2 minus D2. So minus D2, you go here, minus D2, go to, okay, plus RL. So this is your RL, V out. Okay, of course, the negative RL will go to ground. Okay, this is ground. Okay, and then your positive D2 here, go to positive V secondary over 2, and negative will go to ground. Okay, so this is the equivalent circuit. Therefore, you might expect that the KVL also the same, right? Am I right? Okay, so KVL will be same thing, okay? So it will be V secondary over 2. Okay, so since this is forward bias, again, this will become a voltage drop of how much?
0.7.
Yes, 0.7 volt. Okay, 0.7 volt. So this will be 0.7, okay, plus V out peak. Okay, so you will get equals to 0. So V out peak is equal to the same value, okay, 16.27 volt. Okay, all right, now you've done, okay, this part. Okay, so let's take a look at the question again. Okay, so they said that draw and label completely the output voltage waveform across RL. Okay, we haven't finished yet. Okay, we haven't finished yet. So all this solution here is for solution A. Okay, for A. Okay, so now I want to draw the output. Okay, let me add another one slide. Okay, we still haven't finished. We still at the output. Okay. Okay. So still solution 1. Okay. Still solution 1 to draw waveform. Can you understand W/F is waveform? Can I? Of V out. Okay. Okay. You know that. So this is your input. Okay, V input. So you have secondary like this. Okay, if you want to draw like 2 cycle pun, no good. This one, I draw back. Okay, okay, okay. So, oh, oh no, dia padam semua. Okay. Okay, like this. So you have T, this is V input, and you want to draw your V output. Okay, in exam, doesn't matter. You don't have to draw your input. Okay, if the question asks you just the output, just draw straight away the output. Okay, so V input here is actually your V. Okay, doesn't matter. It can be. Okay, draw output waveform. Okay, so this is V input. Okay, so now V output. Okay, so during positive cycle. Okay, so if you can take down this value. Okay, okay, during positive cycle, how much is your voltage just now? During positive cycle, you are able to get, during positive cycle input, you are able to get V out plus 16.27. So you draw like this, okay, plus 16.27. Okay, volt. Okay, and then during your negative cycle, okay, during your negative cycle, you still able to get 16.27. So there you go, 16.27. And so on, back to the positive cycle and back to the negative cycle. So this is how you draw your output waveform, which give you 4 marks for this part A. Okay. Student? Hello?
Yes, Doctor.
Yes,
Okay,
Yes.
doctor.
still here. Okay, great. But you're all clear, right? Understand?
Yes,
Yes.
Doctor. So clear.
Yes,
All
doctor.
right. Okay, very good. Okay. Okay.
Doctor,
Yeah.
for the
Yes.
drawing
Yes.
of the V output, this is for the positive side, for the positive cycle, right?
Uh-huh.
For the negative one, should be the opposite, right?
Yes.
Without the curving, like up and down.
Uh-huh.
Okay,
All
it's
right.
clear. Thank you.
All right. Welcome. Correct. Okay. All right. So let's go to the B part. Okay. B part. Determine the average. Okay. Average output. And what is the effect on the average output V out with the when the frequency is double. Okay. All right. Okay. We know that. So what is actually here? So this is your T, right? T. Okay. So given here frequency. So frequency is equal to what?
1/T.
Correct. 1 over T. Okay, 1 over T. All right. So you can calculate your T lah. So your T will be 1 over frequency. Okay. So this value, if you can put this value to get the complete diagram. So 1 over 50, can someone calculate for me?
0.02, Doctor.
All right, 0.02. All right. So this will be 0.02, 0.04. Okay, let's go back to this question. They said calculate V average. So V average here is actually VDC, right? So let's go back to the slide here. So where is the V average? Here. So V average is equal to the 2 V peak. Okay, this is actually output. Okay, out. Okay, 2 out V peak over pi. Okay, over pi. All right. So you will get that V average. Okay, use that formula. So you will get that B, okay, V average, okay, equal to the VDC equal to the V output peak, okay, V output peak. What was the formula just now? 2 V output peak over pi. Okay, so how much do you get this value? This is VDC, okay, VDC. Go back to the formula just now. Am I writing? Yes.
Yes,
VDC or
doctor.
the V average, V2 V peak over pi. Can someone calculate for me? 2 V peak over pi, how much?
I got 10.35, 36.
10.36. How about the rest of you?
Same.
Same, doctor.
Same.
Same, okay. This is raining here in my place, Johor Bahru, which is nearby UTM. It's raining, heavy raining, so I can't clear very much. But I already make my volume become maximum. Okay, but it's fine. Okay, so 10.36. Okay, 10.36 volt. Okay, so the question asks you again. Okay, what happened? Okay, read again the question, the B part question. Okay, what happened to the V average when frequency is double? Okay, what happened? Okay. Okay. So this question, okay, what happened when frequency is double? Okay, so when frequency is double means that time is going means frequency is double, time is going
Shorter.
shorter, right? So but when time becomes shorter, still the magnitude are still the same. Magnitude doesn't change, because the calculation of magnitude voltage just involved with the V secondary value and the voltage drop of the drain of the diode and so on. Okay, doesn't to do with the frequency. Therefore, if your frequency double or decrease, still the magnitude are the same. Okay, to answer that question, okay, when frequency is double, okay, V output average remain the same. Okay, remain the same. Okay, that's the answer. All right. Okay, so let's take a look at the C part. Okay, determine the peak inverse voltage. Okay, peak inverse voltage. Okay, so C, okay, PIV is given by, what are the equation just now? So V peak secondary over 2 plus V out peak. So this is peak value. Okay, so V peak okay, equal to V peak secondary over 2. What is the formula just now? Plus V out. Okay, plus V out peak. Okay, peak value, not the DC value. Okay, so you will get how much? Can someone calculate for me? V peak secondary just now, V peak secondary over 2, you have
16.97. VP.
16.9 over 2, right?
Yes.
So V out peak is 16.27. So how much is PIV?
33.24 volt.
All right. Did other student try? Please try, okay? Did everyone try? Did you get the same?
Yes.
Same.
All right, same. Great. Okay. So that's it. Okay, for first question. I think this kind of example, this example covers everything we learned today about center tap. All right. So I think I like this example because you can see the real question in the test later. Okay. So this question, I like this question. Why? Because it covers everything. from RMS to the V peak, and then you use the transformer, step down, and then you calculate the voltage output peak, okay, where you convert from RMS to peak, and then you draw the output waveform, and then you calculate the average voltage where you apply the formula for the DC voltage and so on. Okay, so this covers everything for the center tag. Okay, for the center tag. Okay, who have a question? Please ask me now before I continue.
Doctor,
Yes.
is it possible for diode 1 and diode 2 is not the same type of diode?
Diode and diode 2, yes, possible. Could be.
Oh.
But only either one only will on lah. Okay.
Okay, Doctor, thank you.
All right. Okay. Any more question? You have any question?
No, so far.
No, so far. Okay. All right. Okay. Great. Okay. Anyone in UTM right now? Hey, this is not a calculation question.
No, no.
No,
No,
stay at
at
home.
home.
No one answering me.
Outside.
Mungkin tak ada
Okay.
orang kat UTM. Jadi
Oh,
tak ada orang jawab. Mungkin.
I see. Okay. So all of you are at your place. Okay, okay. All right. Yeah, mungkin. So all of you at home right now. Okay. All right. That's good. Okay. Oh, yeah. So next slide. So actually, I will give you this. Although my handwriting are bad, but I think it will be helpful lah. I will upload the after class slide on the e-learning. Okay, later. All right, so that you can do your own revision. Okay. So next slide. Okay, so go back here. Sorry, I always love to go back because we always know the root, okay, or the objective, okay. Always know the objective. Okay, in class when I'm teaching, I know the objective. So my objective is to make sure my student understand what is center tap, what is V out, peak, and so on. So do you, okay. Whatever you do in life, you must have objective. Okay, your objective today, my objective today is to introduce to you two type of rectifier. One center tap, which is done, where you found out, oh, easy. In the end of the day, today you found out, oh, easy. Okay, that's it. I've tried the test one question, looks okay. Okay. Okay, the second one, my objective is to introduce to you the other type of rectifier, which called as bridge network. Okay, bridge network. Okay, like I said, it involved with diode circuit. Okay, for center tap, only two diode circuit, two diode involved. Okay, but in bridge, there will be 4 diode involved. Okay, your objective are the same. Okay, in the center tap, you need to find which diode can be turned on so that your current can pass through that diode, go to your output. That is your objective. Remember, your mission is to allow current to pass through from the input to the output. Okay, which path you decide. Okay, you decide. Okay, it's either you through D1 or D2. Okay, same goes to this bridge network. Okay, it has 4 diode. Therefore, you need to pass through 2 turn on diode to go to your output. Okay, let's take a look how the circuit looks like. Ta-da-ta-da! It looks like this. Okay, so it has 4 diode. Okay, 4 diode. Now the circuit is this one. Okay, looks like this. So this is the what we call it as ground. Oh my god, I'm going to stop this now. Okay, ground. Okay. So this is the real circuit lah. Okay, so this is the real circuit. So you have your transformer, and then you have your rectifier here, and then you have your output. Okay, so let's take a look one by one. Okay, let's take a look one by one. Okay. Okay, I need to take a deep breath first. All right. let's do this. Okay, so you have I want to tiru a bit from the past. Oh, I wrote like that. Okay. All right. Okay, let's go. Lego. Okay, so number first one is for positive cycle. Okay, for positive cycle. Okay, so it has 4 diodes, students. It has 4 diodes. Okay, and resistor. Okay, so I'm hoping that now you are following what I said, and also my cursor and my pen. Okay, so this is input, transformer, and rectifier, and your output Vout. Right? Okay. Okay. Next one. The first positive cycle. Okay, first positive cycle. Okay, when I said positive cycle means that, okay, so you have plus, minus, plus, minus. See, now the difference of bridge, okay, you didn't have a ground at the center of this transformer. Okay, for center tap, you have ground. For here, you didn't have ground. Therefore, your voltage of your primary here, okay, if this is 1:1 is equal to the V secondary. You don't have to divide by 2. Okay, you don't have to divide by 2. So this is how it looks like. Okay, so what is this? What is this one right here? So 1:1. Okay. Okay, so plus on top. Okay. Okay, plus on top, ground at the bottom. Okay, now let's do this. Okay, let's do this. So you have the ground there and so on. Okay, so you know that your current direction is always going out from plus and go back to the negative. So this is your current direction. Okay, current direction. Okay, so this way. So let's take a look from here. Okay, going out from here. So current this way, it has 2 paths. Okay, it's either to go to the D3 or go to the D1, D2. Okay, it has D1, D2, and D3. Okay, now in this case, if it is the objective is, student, listen to me. Okay, the objective is when the current going out from this plus transformer, it must go back to the negative transformer. That is your loop. Okay, when you have circuit, okay, when you have circuit, it has to be that when you go out from this plus, go back. When you're making a loop from this plus, go to whatever diode you have, hundreds diode, go to hundreds diode, and then go to resistor, and it must go back to your negative, okay, to your ground. That is your objective. So as this one, okay, if you go, if let's say this direction, okay, it can go to the D2, it can also go to the D1. Both are making the diode forward bias. Okay, for example, this one go to the D3 first. Okay, let's say I make this, I need to use other pen. Okay, I make this diode, okay, from here to D1. Okay, D3, sorry, D3, and forward bias. Yes, forward bias. Okay, and then it can go to where? It can go this way or this way. So remember that your objectives must go to the output, go to D1, and then go to the RL. Okay, but you don't have way to come back to your negative transformer. So this is wrong. Okay, this is wrong. We don't want that. Okay, how about we go the right way? Okay, where it go to the D2 here. Okay, and then after D2, it can go to the D4, and then after that go to RL, but it cannot go back to your loop negative transformer. Cannot. Okay, so now let's go here. Okay, from this voltage. Okay, and okay, it will go upward here, go to the positive supply, and then go to this current to this way. Okay, it cannot go to the D3 because it will become reverse bias. It will go to the D1, become forward bias, and go to your RL. So that is your loop. Okay, the correct loop. Okay, for this particular forward positive cycle, in this case, Okay, D1 and D what? Forward bias. D1 and D2 are forward bias. Okay, but D3 and D4 reverse bias. Okay, reverse bias. Okay, where we don't want that. Okay, that's it. When you reverse bias, I don't want to know about you because your voltage will be 0. Okay, because your diode is off. Okay, now let's redraw the equivalent circuit for the forward bias. Okay, for the forward bias. So let's draw together the equivalent circuit. I don't know where to draw. Where did I draw just now? Oh, small there. Okay, okay. All right. I can draw there. I can do this. Okay. All right. So you have D1. Okay. Let's draw start with D1. Okay. And then you have plus minus D1. Okay. Minus D1 you have here is RL. Okay. This is your V out. Okay. You know that your RL is always going to negative. Okay. That's it. Okay, that's it. Okay. And then your D1 here. So your D1 here go to plus. Okay, plus V secondary or V secondary over 2? Student?
V secondary.
V
V
secondary.
secondary only. Okay. V secondary only. Okay. So and then the negative V secondary here. Negative V secondary here is connected to. See, this my negative connected to negative D2. Okay, negative D2 and positive D2 to the ground. Okay, so this is your equivalent circuit looks like. Okay, all right. So you apply KVL here. Okay, so you will get that. So can I write my KVL somewhere here? Okay, so KVL will be, because I will be using different color so that you know. Okay, so KVL will be how much, student? Let's start from the V secondary. Will be
Negative V secondary.
Negative V secondary plus
yes,
VD2 or
yes.
VD1, sorry,
Okay, VD1
plus V out.
plus V out.
Oh, I don't know about that.
And here like this. Okay,
Plus
so this
V2.
is, yeah, so this is the loop, students. Okay, so this is a loop. So this loop made, so this loop, your friend said just now, made the first one V secondary. So this current go on plus V2, and then this current go on again plus V naught, and not finished yet. Still has other one more component, which is plus VD2 equal to 0. That's it. Finish. So your loop must cover all component in the loop. Okay. So all component involve the two diode. All right. So this is your KVL. Okay. So if VD2 and VD1 are the same, therefore it will be 0.7 and 0.7. So that's how you do it. Okay. So this is your KVL. Okay. Understand? Clear?
Yes, Dr. Clear.
Clear.
All right, very good. Okay, let's move forward since you already understand for the first part just now, right? So let's do, what color I do for the negative cycle just now? I forgot. Green color. Sorry, yeah, it's matter to me because you will look at the slide again. So color might give you motivation, I think. Okay. All right. So second one. At least it can cover my bad handwriting lah, so that the color give you motivation to study again. Okay, negative cycle. Okay, all right, for negative cycle. Okay, negative cycle now must be negative on top plus below and negative on top plus below. Okay, now let's take a look on the cycle for this case. Okay, for this case, the cycle would be, okay, again, okay, current, okay, like I said, the top one just now, current must go from this way, okay, means that it going out from the plus voltage and go back to the negative. So this is the method lah. Okay. So for this case, you know that current direction must be in this way. Okay, in this way. Okay, in this way. All right. So from the voltage input to the output, that is your mission. Okay, that is your mission. Okay. So let's start from here. Okay, since it is in this way, therefore from this ground, okay, it will meet D2. Yes, D2 forward bias. Okay, and then it will go into this direction from negative to plus. Dr. Izaila said it must be from the negative to plus, and then it can go two-way. Okay, it's either go D2, cannot, D2 will become reverse bias. No, no, no. So you want, you have other one, D4. Okay, D4 will become forward bias. Yes, you want this. And after D4, you can go to D1. That's not your objective. Your objective, you want to go to the RL. So this is your loop. Okay, to the RL. If you want to draw again the circuit, okay, this is how it looks like. Okay, you can draw the other way around, terbalik, or you can also draw in the different direction lah. Okay, so let's draw like this lah. So let's see, I want this as my negative and plus V secondary. Okay. All right, so this is same. So this is your V primary. So this is your V secondary. Okay, so negative V secondary plus secondary. Okay, so now negative V secondary here connected to negative D3. Okay, negative D3. So this is your D3. Okay, and then positive D3 to somewhere here. Let's hang in there. Okay, and then plus V secondary. Okay, plus V secondary to plus plus D4. Okay, and negative D4 go to RL. Okay, and go to, now your ground is upward. You can draw the other way around. Okay, so this is your RL, this is your negative D4 mid plus V naught. So plus at the bottom, negative at the upper side. So this is how it looks like. Okay, although it is look upside down, okay, but still if you apply KVL, you will see it's actually the same thing. Okay, so let's apply KVL together. Okay, let's go KVL. Student, let's start
Yes,
with
Doctor.
yeah,
VSEC.
negative V secondary first.
Yes.
Okay, and then
Negative D3. D3.
okay, how about we start from here, Manzur? Okay, from V secondary and then
Oh,
go.
okay.
Okay, and then you have what?
So VSEC
Okay,
plus
negative V sec.
VD4
Yes, plus VD4 and then
plus V out
V out, correct? And then
plus VD3.
yes, correct. So that's how it would be. Okay, so this is your KVL. Okay, from here, doesn't matter the D1, D4 and D3 as silicon or either diode, you will get your V out. All right. So your output, finally, you will get something like this lah. Okay, so during positive cycle, you get positive voltage. During negative cycle, also you got positive voltage, which is, this is your objective lah. There you want to get the, so this is your positive voltage, and this one is your also positive voltage for the case of positive cycle. So both are getting positive voltage. Okay, you get this. Okay, so this is actually one by one solution for the when you have your R at the center. Okay, but this is actually the same thing happen. Okay, same thing. Okay, same thing what I have explained to you just now. Right. So for the VDC, again the same value. Okay, VM is actually V peak. Okay, VM is actually V peak. Okay, this is actually the same thing. Okay, for the V average, same one. You can use the same formula just now. Okay, that you don't have to see this. You can just apply the VDC voltage equals to this formula. The same thing. Okay. All right. So this is for the bridge, okay? And this is step by step what I have explained, everything here. Okay, everything here, same thing. Okay, so this is a step by step. You can do revision later. So the VIV for the bridge will be this different formula with the center tap, because it has now it has 2 diode. Okay, so this is the formula. You can plug in the formula. And let's take a look on the past year question. Okay, what time now? Oh, 55 already. So, okay, so I leave this past year question with you so that in the next class, okay, please try first. So why I like this past year question, discover all about diode, bridge network, okay, bridge network. So it covers everything here. So from the VRMS to step down. You think you can do it on your own? Hello?
Yes, doctor.
All of you, can you try
Wow.
on your own next class? Next class, we'll do it. We'll see. Okay. Next time I'll continue from here. Is that okay?
Okay, doctor, we will do
All
our
right.
best.
All right. Good. So Nur Elisa asks, Doctor, do we do the same if step up? Same for step up. I think I
Doctor, I
need to
want to
say.
ask, for the
I
bridge
understood.
one,
Mm-hmm.
is it necessary to have 2 grounds?
Like this one, like in this question?
Yes, in the question
Yes.
and the examples that we took before.
Yeah. It's okay. Don't get confused, because when you draw in your breadboard or in your correct circuit, you only finally ground will meet at the same node, right? So in your drawing, you can draw many ground, but in the end of the day, in your real circuit, ground will meet the same point. Okay? So this is
Okay.
just a matter of for understanding lah. Okay? All right.
Okay, all
So,
right, doctor. Thank you.
all right, great. Okay, so we shall do it together. Try first, okay? I hope you try first this, all right? Okay, so I have some announcement now, okay? I will upload the slide and also the recording by today, all right? Okay, are you all there?
Yes, doctor.
Yes,
All
doctor.
right. Yes, please respond. Okay. Okay. So, like later, okay, later in the group, I will show you, I will give you this one. Okay. You will have because in this assessment you have assignment. So assignment, I don't want individual assignment. This must be assessed a group, like the coordinator said, must be in group. Okay. So for section 5, I have about 7 groups. Okay. For section 6, I have about 6 group. Okay. So please fill in this. If you are section 5, fill in your name here. And section 6, fill in your name here. I will share the link later in the Telegram group. Okay. So this is for the matter of your group assignment. Okay. Group assignment and also group activity. Is that okay?
Madam,
All right,
the
doctor.
group member is we by
Yourself.
ourselves or
Or
yourself.
yourself. Which one you comfort? Okay.
Doctor,
Because, yeah.
is it for both codes?
Yeah, for both codes. Because when you register codes, although you are SKEE 1073, you are still section 5 or 6, right? So either one for both code here, okay? If you are
Okay,
SKEE
it's good.
1073 section 5, then you fill up here. Mantul? Okay?
Yes, doctor. Can you
All right.
repeat?
If you are SKE 1073
Yes.
section 5, so you fill in your name here in the
Okay.
section 5 tab. Okay?
Okay.
All right.
No problem.
Okay. All right. So yeah, I think that's it for today. Yeah, please install the
Multiple.
multi-sim, please. Yes. I'm showing again the attendance because your friend made it. Okay. So multi-sim, to be honest, the pirate one will do the same as the good as good as what the trial version one. Okay, but it's matter of pirate lah. Okay. All right, that's it. Students, I hope you are happy. When you end of this class, you are very much clear about the center tab as well as the bridge. Okay, so for those who haven't scanned, you can scan your attendance now, and the rest, bye-bye all. See you all on Wednesday. Okay?
Okay, thank you, madam.
All right, okay.
Thank you, madam.
Welcome.
Thank you,
Take care
madam.
all.
Thank you, Doctor.
Okay, welcome. I will share the slide
Thank
later.
you,
Okay?
Doctor.
Welcome. Bye all.
Thank you, Doctor.
Welcome. Take care. See you on Wednesday.
Thank you, Doctor.
Okay, welcome.